In this example, I need to solve the following equation over the interval 0 to 360 degrees. If necessary, I need to round the answers to one decimal place. The equation is cosine squared A plus 3 times cosine A minus 2 equals 0. Well, what type of equation do we have here? Notice it's a trigonometric equation. There is only one trig function present in this equation. That's the cosine function. And there's only one argument of the cosine function, and that's plain old A. So this is an equation in cosine A. What's the highest exponent on any of the cosine A's? Here I have a degree 2. Here's a degree 1. So this is a quadratic equation in cosine A. How do we solve quadratic equations? We want everything on one side written in descending order, 0 on the other. Well, that's already done in this case. And the simplest method for solving a quadratic equation of this form is factoring. However, it doesn't work in this case. So I'm going to have to use the quadratic formula. So I'm going to compare my equation to ax squared plus bx plus c equals 0. And then I'm going to use the quadratic formula given here. So the first thing I have to do is figure out a, b, and c for my equation here. Little a is the coefficient of the squared term. So what number is in front of the cosine squared a? It is just a 1. B is the coefficient of the linear term, the cosine a term, so it is 3. And c is the constant of negative 2. So now I don't have the variable x. My variable is the cosine of a. So it equals negative b, so it's the opposite of b, which is 3, so that's negative 3, plus or minus the square root of b squared, which is 3 squared, minus 4 times a times c. 4 times a is 1, and c is negative 2. All of that is underneath the square root, all divided by 2 times a, which was 1. Simplifying, I get negative 3 plus or minus the square root of 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 2 is positive 8, all divided by 2. Which equals negative 3 plus or minus the square root of 17, all divided by 2. The square root of 17 does not simplify, so I'm going to have to find decimal approximations. So I'm going to say the cosine of A equals negative 3 minus the square root of 17 over 2. Or the cosine of A is negative 3 plus the square root of 17, all divided by 2. I'm breaking it up into its two solutions. Now I need to go get my calculator. In this case, I'm using a TI 84 Plus Silver Edition, and I need to get approximations for these two numbers. If you do it in one step, be careful, you must put the numerator in parentheses. So I'm going to have open parentheses, then negative 3. This is the negative key. This is the operation of subtraction. So negative 3 minus the square root of 17 minus the square root is second x squared of 17. Notice I'm still under the radical, arrow over, I'm not under the radical, close parentheses, and then finally divide it by 2. There's my first number, and now I need to do the same for this one, so it's parentheses negative 3 plus the square root of 17 divided by 2. And there are my two approximations. I paused the video to copy down my two decimal approximations, but please remember that the cosine of A has to lie between -1 and +1. Looking at our first solution over here, is this number between -1 and +1? No, therefore there are no solutions from this part of the problem. But now looking at the second part, is it possible for the cosine of A to equal 0.56155, etc.? Yes, that number lies between -1 and +1. So now I can find one solution for angle A using the inverse cosine function on my calculator of 0.56155, etc. So going to my calculator, I need to make sure I'm in degrees. So go to the mode, and I'm in radians. So I have to scroll down over, hit enter. Now I'm in degrees. And now I'm ready to find the inverse cosine, which is second cosine, the blue one up here, of, I don't want to have to retype this number, that's being stored in the answer, which is up here in blue, so I'm just going to hit second answer. Close parentheses and hit enter. So my answer is 55.83 ... And it's said to round it to one decimal place, so that 3 is not going to round the 8 up. So one solution is A equals 55.8 degrees. So I found one solution between 0 and 360, but is the cosine function also positive in another quadrant? Yes, it's also positive in quadrant 4. So I need to move my calculator for a minute. Please note that the angle I have already found is in quadrant 1. Any angle in quadrant 1 is equal to its reference angle. So the reference angle for this angle is also 55.8 degrees. And then drawing a quick sketch to get my angle in quadrant 4, this is the angle I'm looking for. It will also have a reference angle of 55.8 degrees. And remember, the reference angle is the acute angle between the terminal side and the x-axis. So I know this angle is going to equal 55.8 degrees. So the angle I'm looking for in quadrant 4 is going to equal one whole revolution, which is 360 degrees, minus the reference angle of 55.8 degrees. So A is going to equal 360 minus 55.8, which is 304.2 degrees. So my second solution in the interval 0 to 360 is 304.2 degrees. And that is the angle that is in quadrant 4.